The differences between petrol and diesel engines, aka gasoline and diesel engines operate on the same 4-stroke cycle. This starts with the intake stroke where the piston descends, sucking air into the cylinder through open air intake valves as fuel is injected. This is followed by the compression stroke where the valves close and the piston goes back up the cylinder to compress the air and fuel mixture. The third step is the power stroke where the mixture is ignited to force the piston back down the cylinder, and then the final exhaust stroke occurs where the ignited fuel and air mixture is pushed back out of the cylinder by the piston through the exhaust valves. Where petrol and diesel engines differ is how they ignite the air and fuel. To understand the difference, we need to understand the self-ignition temperature. This is the temperature at which an air-fuel mixture will ignite without the use of a spark plug purely due to compression. It's this compression that allows the air and fuel mixture to ignite in a diesel engine without the need of a spark, because the greater compression, the higher the temperature. That's why diesel engines have higher compression ratios compared with petrol engines that don't compress the air and fuel mixture to the point of ignition. If you don't know what a compression ratio is, let me quickly explain. Simply put, it's the ratio of the maximum to minimum volume in the cylinder. So a ratio of 10:1 means that when the piston is at its lowest point, there is 10 times as much volume as when it's at its highest point. To give you an example of compression ratios, a 20 will have a higher compression ratio to ensure that the air and fuel mixture is compressed enough to the point of ignition, while a petrol engine uses less compression and is ignited by the spark plug, though no into the engine. More air means the injectors send in more fuel, and more fuel means more power. Where petrol and diesel engines differ again is how they're able to engine brake. Diesel engine vehicle with no throttle body, engine braking occurs during the compression stroke, where the exhaust valve is open to allow pressurized air to escape. And the reason so why exactly are diesel engines more efficient than petrol engines? One of the many reasons is down to the fuel itself. Diesel is comprised of more long-chain hydrocarbons, which simply means it's got more energy than petrol. In fact, it contains about 15% more energy by volume, roughly 36.9 megajoules per litre compared to petrol's 33.7 megajoules per litre. Diesel engines are also more efficient because of the thermal efficiency gains you get from igniting the air with high compression, rather than a petrol engine's lower compression ratio that requires a spark for ignition. And that's because a turbo feeds compressed air into the cylinder, which helps the piston descend into the cylinder, therefore saving energy. So now that you know the inner workings of a petrol versus a diesel engine, which one are you a bigger fan of? Let us know in the comments below, and remember to give this video a lovely thumbs up.